Hello everybody, it's been some time, I know, I apologise, but work got in the way. I was laid off, but then 3 months later the company rang me up again and said would I go back to work. So having been laid off for 3 months, which gave me plenty of time to produce all the previous videos, I've had no time to do a new one, but we're just about to change that. This is a starter for 10 for the new Avondale CAP 6 power supply module, supplied by Avondale, 2020 version. It is a much more substantial piece of kit than any previous. I think it's 2.4 millimeters thick. It's the actual copper is twice as thick as normally produced by Avondale. So this is just going to be a run through on how to build one of these up if you're lucky enough to get a kit off of the company. You'll need some, these are some of my favourites, which are if it will focus, don't know if you can see that, MBR 2200s rectifying diodes, 200 volt. Comes with a heatsink, which you attach these to, and I'll run through that as we move forward. So no further ado, first things first, I like to put on some feet or some standoffs. So just to the right here I've got a bin full of bits that I'm going to need. 1, 2, 3, 4 of those. We've got 4, in actual fact they're countersunk screws that we use, or I'm using in this case. 2, 3, 4. Because it's a simple matter, put your screw in, which centres it in the hole. We'll nip these up in a minute. Just like that. Thus, there's a screwdriver, wrong screwdriver. We just nip these up. We don't have to be over tight, just a nice firm twist. Thus. So now we're going to start populating it with some components. These are chokes, again supplied by Avondale, nice little neat things, and they go on the bottom. There's one there, one there, one there, and one there, just like that. And this device filters out any ripple, any or noise, if you like, in between the capacitors. So this heatsink for the MBR 2200s is attached like that. There's some screws, there's a couple of little nylon or fibre washers that stand it off. So what I'm going to do is attach these rectifiers onto this heatsink. So you need a bit of insulation because the actual tab is live. So we're going to insulate it from the heatsink. So I'll do one at a time. I'll do one, show you one, and then we'll go on and do the others. So you need a little nylon bush that actually fits. This fits in there like that, and then we have a little cap head screw that goes through there, through the insulator, and then we can affix it to the heatsink. So at this stage I'm just going to nip it up. I'm not going to tighten it, just nip it up, just like that. So I'll go along and do all four, and I shall be back. So I've fitted these. Quite simple. I haven't nipped these up tight, they actually move because we have to align them with their requisite pinholes here. So that bit's a bit fiddly, but we'll be doing that later. But what I'm going to do now, starting at the shallowest elements, I'm going to solder these in place. So I'm just going to flood those pads. Sorry. I'm just going to put a bit of jollop on these pads. Roughly like that. Like so. I'm just going to tin these legs. Just a little bit of solder on there. These come in all sorts of shapes and sizes. You could, instead of using these chokes, as they're known, you could use a resistor. I've done that before on a previous video, I believe. And indeed you could use a choke, then an R, CRC type arrangement. So I'm working around the camera here. I hope this will be okay. So we just flood him on there like that. Turn him round. Flood him on there like that. Bit boring and repetitive, but just to give you an insight of how to do it. Like that. So now we have the 4 chokes in place. You could flood the whole pad if you wanted. I don't see the point, but you could flood the whole pad. When I started earlier, and you can see I've flooded the whole pad, but I don't think it's necessary. So that's that element of the business out of the way. So now we've got to fit some spades so that we can connect all the wiring up. Here's the spades. Now these are a very tight fit in here, and what I like to do, or have done in the past, is just nip them up with a pair of long nose pliers. A nice snug fit, and I'll carry on and populate this, and we'll be back. So I've now got these male spades. They're just located onto the PCB. I'm just now going to go and solder them in situ, put them in place. So if I knock the camera, I apologise. Hope you can see this. Yeah, it's fine. So we're just going to go along, flood each one of these. Boring, boring, boring. Because this PCB is a bit thicker, or substantially thicker than previous Cat 6 boards, you do have to apply or hold the heat for quite a lot longer in time for it to take, if you understand my meaning. I think I've put enough spades on. I shall work it out and get back. The spades, you need enough to supply the power amp board with DC, plus a couple of zeros, which I'll cover later. This will be used ultimately. In a previous video I built an NCC300 power amp using switch mode power supplies. Now it works very well, but this is just the next step, incarnation if you like, using all Avondale products, which is going to be Cat 6 and his transformer, the twin core transformers. But that's the next going to be in the next video. But for now, we're just going through, as I say, this 2020 in actual fact, what I like to do, it hasn't flooded, because this board is quite thick, it hasn't flooded right through to this side. Normally you would see a pool of solder that's come through the through-hole trace, . So on the next one I might just yeah, that's better. I might just hold it for say 7 seconds. These I've been holding for about 5 seconds. And I'm just flooding these, as you can see, back through, so we know we have a very good connection both sides of the board. Like that. Just like that. I hope you can see it. I'm not sure you can or you can't, but I think you get what I'm trying to show here is make sure you've got a very good connection through the legs of this spade. Good contact. That's better. Happy with that. Lovely jubbly. Okay, so my next protocol. Now we have some pads here for LEDs, which in this case I'm not going to use these, but if you wanted to spark them up with LEDs, you would have to put a 4K8 resistor across these pads from 0 to positive and negative. You could mount the LED directly in here or have some flying leads going somewhere else. I don't tend to use these, but by the by, if you wanted. So now my next highest element is this heatsink with the rectifiers on, and these aren't actually fixed per se. They're just loosely in position, and you'll see why, because they're a little bit fiddly to line up, and we'll tighten them up after the event. Once they're all in, I can actually move these backwards and forwards so that I can line all these holes up. So that's what I'm going to do next. So the trick is to get one in, he says, get the next one in, then get the next one in, and then get the last lined up like this. There you go. The legs stick through. I'll solder those in a second, but what I'm going to do is use a little fibre washer which goes under here, and that just lifts this heatsink off the board. Like that. On the other side. Oops. Again, just a nip. So now they're in situ, I can just nip these up. They don't have to be over tight, as long as they're a nice firm fit, like that. And now I can go along and solder these legs on. But before I do that, what I'm going to do is just check some continuity, make sure we haven't shorted anything out. So I've got my meter, a couple of leads. I've got a couple of leads here somewhere. Here we are. These will do. Lovely. So I'm going to come off here. Well, nothing. Nothing. So there shouldn't have any continuity between the fixing and this tab via these insulators. Nothing. So there's no shorts anywhere there, so that bit is checked out. So I'm now going to solder them in place. So another boring bit, I do apologise. This you have to be a little bit careful here, bit of due diligence if you like. Get the PCB in the appropriate place. Just clean that rubbish off of there. Better, because there's not much space between the pads here, so it's a matter of flooding. Flooding. Sorry if I'm knocking this camera. There we go. And they've all nicely flooded up through to the top side of the PCB. Normally I would trim all these legs off, but there's so much space between the standoff and the leg of the rectifier, I'm not going to bother. So all that's left now really, in this first instance, is to populate it with capacitors. And I just happen to have these, they are Nikon. These are 85 degree. I couldn't get hold of 105, but they're 10,000 microfarad, 80 volts. And we're going to be running about 63 volts, so we're well within the 20%. And I've got a big bag of them. See, these are brand new, date stamp 20, yeah, 20. This bar here, negative, goes on the negative side of what's marked on the PCB. Positive positive, positive, negative. So we just unwrap them. Positive, negative. Push fit, snap fit, whatever you like to call them. I don't tend to test them. They're brand new. I take it as read that the manufacturer, in this case it was RS, Radio Spares Online, are supplying me with these, and that they are good. I suppose in theory you should check every single item, but in the 20 years I've been doing it, new capacitors are new capacitors, and I've never had any issues. I used to check every single capacitor with my meter, and I just got fed up with it. Pointless, in my opinion. You wouldn't get on a production line, I don't believe you would have a machine checking every single capacitor before it goes in a circuit. Again, they take it as read that the manufacturer is supplying you with the product that's good enough. So I'm just going to flood these in now. And because this PCB is quite thick, you don't get so much of the leg poking through. So I just take my time, get a nice jollop on there, work it in. As mentioned previously, this power supply module is going in a NCC300 mono block. Now I might use two of these per mono block, as in a Voyager type, what's known as a Voyager type setup, whereby you have one power supply supplying the output devices and a second power supply or another winding off a transformer supplying the front end, which gives you a lift in delicacy in the resultant sound, and it's much preferred. So apart from testing it, I'm just double checking. Negative, 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 negative. We know that's on there. We got our L's, we got our chokes on. Everything's solder. I'm going to put some stuff away. We'll come back and we're just going to check this to make sure it actually functions correctly. So I have a benchtop crocodile type supply that you can connect up various devices. I've got this Avondale AST type 9060 transformer with two secondaries. The green is the 0 and the yellow and white are the AC mains lines, and we're just going to see what it produces. It's actually going to give us 37 volts AC. So we're now going to connect this up to our power supply module. So the green is the center tap 0, that goes on there, and we got AC either side. AC, AC, center tap 0. I'll put that in the center just for clarification. There we go, 0. These are a nice tight fit. So now what we're going to do is see what this thing actually produces. I've got to change these leads. I've got another meter with another set of leads somewhere, but I don't know where they are. These will do. These will do for now. So now we're going to get DC out of this device. Hopefully it won't go bang. So black center, red we should have positive DC out of here. At the moment it's reading, so there is something on it. There we go. So we got 50 volts positive, 50 volts negative. So that's working superbly. So in effect that concludes the build of this CAP 6 module, the 2020. There will be a follow-up, as I said earlier. These I'm going to build another one identical to this. This is going to go into a NCC300. I might use there's two secondaries on this transformer. I might use one for the front end and one for the output devices. I haven't decided yet. Wait and see if I've got room to put it in the case. So this is the power amp itself. Remember we had switch mode power supplies. And what I'm now going to do is take that out and replace that excuse me, with a conventional transformer. This is one of Avondale's mighty IST transformers. It's 540 VA, something like that, and a power supply which you've seen in the previous video, and this will then form a more conventional power supply. Whether it's better, I think it does, it adds more weight to the resultant sound, but cost, this is a great deal more expensive. So what I will do probably is put a second, as mentioned, second power supply in here. So one will supply the output devices via these two and some wiring, and this one will supply the front end, this section of the board here, this front end. But initially I'm just going to do this one, and this will supply the whole board. And I'll go on and install this. I've got to drill some holes, got to drill a hole for the transformer. The wiring's almost ready in place from the previous power supply install. These will be laced across here somewhere, neat and tidy, and then I'll wire up these to here. I've got to put some spades on the end of these wires. It's just a simple matter of wiring it all up. So, but for now, thanks for watching. Thanks for all your interest. Thanks for all the thumbs up everybody. I hope it's still of interest, and I'll see you in the next video. Keep well, keep safe, and keep your head down. Speak to you soon. Bye.